Guys, as you know, we have started the mock interview series of around 20 to 30 videos for data engineer. So this is going to be another video of the same series. Trust me, this video is going to add immense value in your data engineering and interview preparation journey. So hey everyone, my name is 𝗵𝗃𝗃𝗃 and without wasting any time, let's start the interview. But before that, do subscribe to my YouTube channel for the upcoming videos and join my WhatsApp channel for more data engineering stuff.
So I see
Yes, yes.
you have worked majorly on the data pipeline and that too on the AWS tech stack. Okay. So let's begin with how did you were you involved in designing the pipeline, or were you only responsible for maintaining the pipeline, or what were your roles and responsibilities in that?
Okay. So my role is to design the pipeline.
Okay.
Actually, we receive the semi-structured data from that FCA. So we use they gave me the XML around 50 GB files.
Okay.
So XML, we parse those XML based on their XSD schema. So after this, we pass those semi-structured data to a structured format like CSV.
Okay.
So from there, we write those data back to S3.
Okay.
And then pick those CSV files and do some action transformation, set of action transformation, and then we apply that, load those data to the Amazon Redshift.
Okay, so can you tell me the various components that were involved in your pipeline? For example, like you have mentioned S3, right? Like how the data was coming into S3 or reading from S3. Where were you using Glue for transformation? What were the various AWS components that you have used?
Okay. So for data ingestion or data pickup, so we use Spark data frame from read to from S3, and then from there we implemented the script to validate those data. So we use Amazon EMR from there.
Okay.
EMR. So there are different AWS steps. We use AWS step for orchestration. So mainly what happened, there are different stages in my project. So first stage we have to do is data validation steps.
Okay.
Then data parsing steps. Then a stage load, then main load. So what happened in there? So we define those orchestration in AWS step function.
Okay.
So whenever we submit the Spark command in that means running our EMR cluster. So they started progressing from first steps to last steps in Amazon EMR,
Okay.
AWS EMR. So from there we can check the errors and all those things we can access through Amazon EC2. We are using Unix in there.
Okay.
So after that we verify those data in Amazon Redshift that my data is loaded correctly or not.
Okay. So I see you have started with S3, reading from S3, then you have used Amazon EMR, and then also step function for all the transformations and everything, and then in the end loaded into the Redshift tables, right? In the Redshift.
Yes.
Okay. Yeah. So can you tell me how much time does it was it a daily run, or is it a weekly run, or what was the schedule for running this pipeline, and how much amount of data you were receiving on a day-to-day basis or whenever the pipeline runs?
Okay, so it actually in one day the pipelines runs means up in the interval of 4 hours.
Okay.
So in the interval of 4 hours, so sometimes we receive around 40 GB of data, sometimes it's around 60 GB of data in XML format.
Okay.
So in zip file actually. So we extracted job zip and then validate those file name structure according to business requirement.
Okay, so you mean your data is varying between 40 GB, it could be in one run 40 GB, then in 60 GB. So how do you handle this varying size? Like for example, what is the duration of average duration your pipeline runs? Like for example, if a file of 40 GB coming, how much time does it run for?
It's around for one steps for file validation, it's around 10 to 12 minutes.
Okay.
For each steps, if we consider each steps then it will run around 60 to 70 minutes around it's run means on one batch for one batch. Yeah.
Okay, for one batch, only validation takes 10 to 12 minutes and later process takes 60 to 70 minutes.
No, for all the files. 10,
okay, complete file.
complete
The whole
files.
pipeline
From
completes within 60-70 minutes. Okay.
uh,
So your pipeline runs for 4 hours. Then the
Hmm.
fifth hour is completely into the transformation and accepting that thing, right? Okay.
Hmm.
Okay. So tell me, like, how do you handle this varying size? Like, what are the steps you have taken to see,
Okay.
like, definitely when the file is coming of 40 GB, that to an XML, you would process within shorter amount of time. You wouldn't take 60-70 minutes. But if a file says today you have got 60 GB, tomorrow 80 GB, how would you handle this?
Okay. So actually, what happened when we received less GB of files?
Okay.
Then there are two. We follow two process.
Okay.
For those medium level files, we use instead of EMR, we use AWS Glue.
Okay. Okay.
And in a step function, we write those things. And for large XML files, we use Amazon EMR.
EMR.
So
Okay.
for that basis, we implemented those optimization, optimizing cost and everything.
Okay, so like, how do you decide? Like, do you perform a count check on that, or do you see the file size check? What is the parameter that you are deciding whether to go with Glue or EMR?
Okay, so in whenever we receive the file, right? So there are some means in a Spark submit command, we write those memory and executor what are the executor memory we have to take in, like whatever the so in that we extracted those files, and then we in S3 we have like in S3 properties they tell me like what the file size is there.
Okay.
So
Okay.
according to that, we partition those files and load the data.
Okay. Okay. So based on the file size, you are deciding to go with Glue or EMR. Okay. Okay. That's you understand. Then like how do you handle the this varied form? Like it's an unstructured format, right? Like you from the unstructured, the XML is coming in unstructured, and from there you're converting into a semi-structured, right? Like if I'm not wrong, completely
No,
structured.
semi-structured to a structure.
Okay, semi-structured to structure. Like how do you
Yeah.
do this? Like are you using
Okay.
PySpark, and what are the transformations you
Okay.
use?
Okay, so in that, right, we don't need PySpark in that. We use Pandas data frame in that.
Okay, you work in.
So Pandas and Python. So what happened? Like there are some file formatting. First, we use 𝗖𝗄 library for parsing those XML files.
Okay.
𝗖𝗄, and then we iterate over that complex type there in XML format. What are the tags like complex types, simple types, tags are there. So what happened? We iterate in each tag and extract the important element like what are the pricing, what are the things. We write those like in and extracted those key with particular in particular column, like pricing columns got this amount, and then their x paths is goes to from here to here, like that. We implemented all those stuffs in that parsing script.
Okay, and like I've heard like you're using pandas for this. Like, but in the very beginning you said like you're using a Spark to read the data, right? So you're reading the data as a Spark data frame and then converting into pandas, or
Yes, actually, what happened now in pandas we can't able to like read those large files.
yes, that's
So
what.
in between when we convert those CSV, right? After the CSV conversion, then we partition those data as a file format in that S3 according to that CSV. So if we consider like in a month, if it is a January file, then all the January files are if the particular month is Jan, in one partition. So from that one partition we can run through then pandas.
Okay, so you read the data, partition the data, store it in S3, and then connect use pandas to read that partitioned data.
Yes.
Okay. This part was missing. Okay. Now I understand. But don't you think like Spark is obviously faster than pandas, right? So why do you have to worry on like I stick to pandas? Any reason for that?
Okay. Actually, what happened now in PySpark, there are some distributed framework.
Yes. Yes.
So the cost main thing is the cost. So we if we have means if you have option to do pandas, then we can do from there. Yeah.
Okay,
so we don't use them. So
yeah, but okay, just a thought to it. Like, see, you have got PySpark, you have got Spark and Pandas. Pandas is single thread, whereas in Spark you can do
Hmm.
multi-threading and finish the task
Multiple.
fast, right? So, but don't you think Pandas is like less efficient here because we can use the benefit of parallel processing and finish like right now it is taking 60 to 70 minutes for your whole job, right? It could take much more time, less than what it is taking right now. So, do you look for that
So
optimization
actually,
or was it
yes, actually, we have done those POC in that project. So
okay?
what happened? There are sometimes like there are some joins in there in the code.
Mhm.
So what happens is like Panda means Spark shuffle those joins drastically. So like so it takes sometimes time, it takes time, sometimes taken less time. So due to undistributed characteristics of that PySpark, we use Panda in that.
Okay, okay. Okay, so yeah, that's understandable. Now, like, have you used SQL also in that, or like there's
Yes,
no SQL part?
yes. We use that like we have like implemented some key value in that code.
Okay,
Like and those key values we are storing in that Redshift. So
okay,
we use os.get environment to pick that key and from pick that means read that key and their particular value and then implementing those SQL things in my job.
okay. So okay, for that you're using. Okay, so yeah, like I'll move on to the like very other questions. Like you said, you have mentioned good with Spark and PySpark as well. So can you explain me the concept of Spark? Like how does Spark work and why we call it as a lazy evaluator and something like that. So
Okay, so
what Spark?
like there are some in PySpark there are some driver and then executor
Okay,
and there one is cluster manager.
okay.
So what happened when we start a Spark session?
Mhm.
So a driver execute those from end to end. So what happened? Cluster manager allocate those memories whatever we submit in a Spark submit command to the executor.
Okay.
So what happened whenever we write the Spark code?
Mm-hmm.
So there are some actions and transformations as we
Okay.
said. So
Okay.
like whenever the for lazy evaluation, whenever the transformation is like it's maintaining one DAG.
Okay.
So what direct acyclic graph. So there are some what happened. So they maintain one cycle stages to perform those transformation.
Okay.
So before means after action hit, then that transformation work. So that's why we called it as lazy. So what happened when driver submit the code to like when cluster manager executed when driver submit the code, so executor starts working on that.
Okay.
So after action hit, then executor write those result back to driver.
Okay. Okay.
That's why it's lazy evaluation.
Okay. So, okay. Okay. Right now, when you say like when an action is triggered, the data is returned back to the driver node. Okay. That is fine. But what happens if one of my, say, for example, I've got four workers. Okay. One master, four workers, and one of the worker goes down. Okay. Then now I've got only three. So what happens to the fourth worker? Whether it will restart or whether it will like lose all its data? What happens in this event of failure?
Okay. So as you know, like it's a parallel process, right?
Yes.
So as Spark cluster manager execute cluster manager allocate resources to them. So whenever cluster manager gets like if one of my executor fails, so it will transfer those data to parallelly to other three executors.
Okay.
Like that,
Okay.
to maintain the parallelism.
Okay. 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 So, okay, this is understandable. Then, like, do you have heard about the concept of cache and persist?
Yes.
Yeah. Why do we need them?
Okay, so actually what happened now, whenever we do the data, we store some data in some particular data frame.
Right.
So if you want to store, if you want to again doing some transformation from that data frame. So we need to do that cache, so that we can store those data frame in cache, so that we can't ever, means my executor can't do again and again for that data frame. Means what we call it like computation. Yeah, computation. Executor can't do that computation again and again for that particular data frame. So we use df.cache in that case.
Okay. Which is beneficial, cache or persist? And where does it store the data? On the disk or in memory, or where does it?
Okay. So by default, they are storing data in memory.
In
so
memory.
both.
Okay.
Yeah. So whenever data spills, it means if my data volume is large, so it spills to from in memory to disk. So there are 3 parameters we define in that. So in that it's memory, one in memory, and then memory and disk only. So we define 3 parameters inside that cache and persist. According to that, we use that, and for both of point for that point of view, we use like cache. Mainly we use cache in that case. So yeah, that's the.
Okay. So then, do you know the concept of skewness in Spark? Like, it's an enemy of Spark, right? Skewness. So what is it? Skewness. Data
skewness.
Yes.
So I heard a little bit, but didn't know that. Matlab means that concept. Like there are means if some data are like anomalies are there. So actually, how can we handle? I don't know the process, but know that.
Okay. No worries. Like maybe like since you are working on the data, right? Like you said, like your data is getting partitioned and in the storing in the buckets. So there could be a possibility, right? For the 5th day, like for example, like you have 1 week of data for the January month. 1st, 2nd, 3rd, 4th, you have got consistent data. But on 5th, some big event happened due to which there was a sudden increase in the volume. And 6th and 7th, there was no huge volume. So when you process, there would be difference in the time. So like yeah, this is a concept of skewness which would help you to okay, no worries. Like you can learn about it. And okay, so let me give you a scenario. Okay, now you have a data in S3. Okay, like I would like you to design an ETL pipeline. Okay, end-to-end pipeline. And what are the basic checks and some of the things you would like to take care of while designing the ETL pipeline? Okay, so I'll just give you some examples. Okay, you have to read the data. It's a web scraped data which is residing in S3. So you have scraped the web and got the details stored as a CSV in the S3. Now you have to access that S3 bucket, read the data, perform some sort of transformation. I mean, you can take your own examples. Like it has got date time format. It has got some aggregated columns, some numerical columns which can be aggregated, all those things. And then you have to store that in the say back to S3. Okay, this is one scenario. And if not, you have to store it in a Athena table or a glue catalog. Okay. So how would you design the pipeline, and what are some of the checks you would like to keep sure to make sure that your pipeline doesn't fail? And even in the case of failure, you are able to pinpoint the failure. What could be the possible reasons?
Okay. So if my data is in S3, so first we use for interaction purpose, we use GoTo3 to read those data. So we use GoTo3 to read those data, and after reading those data, we checks like my data is picked properly or not. Okay. So from there we can use a step function. So what in that case we use in a step function we use AWS Lambda in between to like trigger a message using SQS to send a notification service to stakeholders that that data is proper in the we received or not. Okay. So if these checks pass, then we do that whatever the aggregation and those stuffs. If the files, if we can check the file size also there, but if the file size is normally range in between medium level, then we can do that transformation directly. And
Okay.
after that we can load those data to Athena, whatever our means we can query those data from Athena. In Athena we can also like query from S3 to check. So like so from there we use that for every step in a step function we use that notification service.
Okay.
That my data is here with in which state, like a state is fail, count, whatever the count we received, whatever count. So we can all those details in that SMS service.
Okay.
And then we after transformation we load that at a staging layer, so that we use truncated load format in that case. So what if we load some data, if they are already there, so we truncate those load data and then again load the refresh data.
Okay.
So what happened, we again checks that there are not a duplicacy in that. So from there we can also use AWS Lambda at that time. What happened if the data, if the my count is like less than or something not equal, we actually check the count from receiving to receiving to a target, receive to target.
Okay.
So again we use that, and then finally we put those data to main table for downstream use cases.
Okay. So, I mean, you have said a very good pipeline, but what are some roles and like, for example, like one area which we as a data engineers, we try to overlook is the permissions. Okay. So for accessing the bucket, right?
Okay,
you are
so
using
yes, okay, we can use. There are some certain things. I means for overview I have given, but there are some certain things like ARL we have to pass for EC2 for permissioning bucket. We use identity access management.
Yes.
For that, and we give permission for S3. We give permission for AWS Lambda. We give permission for AWS SQS like that.
Okay. Okay. Yeah, like these are the some things which we need to take care of while designing pipeline. Okay, so yeah, that's a really good answer. Then tell me, like, okay, so now you have partition data, you have kept the data. Are you aware about the concept of schema evaluation? Schema, like
Schema evaluation, I know.
Okay.
Yeah, those metadata things, right?
Yes. So how would you handle that? Like, for example, your data is coming properly for 1 week, but on the next week onwards, there is a new field that will get added. Now, how do you handle this in?
Okay. So whatever now, we use AWS CloudWatch. So whenever we run the jobs, there are logs generated in each step. We debug that code. So what we have done, we have implemented print a schema in that.
Okay.
So
schema. Okay.
Print a schema in that case. So df.print a schema is a one term. So this term print my schemas and their respective sizes in that logs.
Okay.
So we means before implementing AWS Glue or anything, we use those like we need to add the new field or we need to change the data type of that field. We do from there. After seeing those logs, we can do from there before loading to final table.
Okay. Okay. Have you heard about the concept of merge schema and override schema, true, false, like while writing a Spark data frame? That would be more helpful. Like what you're saying is an ideal scenario where you would like to compare the schemas, like what is the original schema and what is
it's a brute force scenario. Yeah.
Yes, yes. So you can do this with the help of override schema or merge schema as well, which would help you to do these things. Okay. Yeah. So can you tell me about the various data types you have worked on, like various data types and also the file formats?
Okay, so in this duration, I work on like CSV, XML, mainly CSV and XML, and for data types, it's like a string, then integer, then float, and then some things are like we can okay, date and date.
Okay, date time format you have worked on. You have worked on the date time format, right? Okay, so yeah, one more. I would like to give a coding question, but before that, like, are you about the difference between a row storage and a columnar storage? Like which file supports which type of storage, and when should we use what type of format?
Okay, so Parquet is columnar storage. So we didn't use Parquet here, but Parquet we use for columnar storage. And for rows, we can use we can use CSV, and then we can use XML as well for suggest.
Sorry.
For Parquet, we use for that columnar storage is like.
Okay.
And then for CSV, we use row storage.
Okay. Okay. So I'll be giving you a small uh, coding problem where basically it has what are timestamp columns. Okay. So I would like you to read that data. Okay. Then see and break down that complete event data into a week time. Okay. A weekend. Okay. I'll give you the data type first. Okay. I'll be pasting in the chat. Okay. So this is your column. This is the data it has. Break. Yeah. So I have given a problem statement in the chat window. Okay. I'll just brief you on the problem statement. So there is a column. Okay. We'll go with a single column. I have eradicated the other ones. There's an event column called as event timestamp. And the data is coming in some time format, like date time followed by the time. Now I want you to break this combine data into a separate date format. I mean the date, which is 2023-11/4, then hour, which is the 15th hour, okay, and minutes, which is the 23rd minute, and the day of the week. So 4th of November 2023, what date it is. So can you write me a logic for this? Maybe you can share your screen and write the logic. Hello, Ashish, you there?
Yeah.
Yes. Okay. I can't
Is
see.
my screen visible?
Yeah, it's visible now. Yes. Yes.
Right.
Yeah, maybe a notepad or editor, whatever you have.
This is a table name. It's
Yeah, you can take it as a table. I
hello.
mean, it's just a table. Any name you want, you can give.
Okay. So okay.
First, maybe you can write some steps like how would you do this? Maybe you can walk me through the strategy you have, and then we can get onto the coding.
Okay. So what I can do here is like you can extract you can read files like in that using for row by row. So what I can do is like Okay, so this is my logic.
Okay, so you are saying that you would read the table, apply for loop in the about data for each row. Okay, why do you want to apply for loop here? I mean, first of
To
all,
read each
which
row.
format are you writing in? Like, would you write in PySpark or Pandas? Which way are you going?
In PySpark.
You will be writing in PySpark.
Pandas.
Okay. Sorry? You'll be writing in PySpark or Pandas?
Yeah, we can slide. We can use Python plus Pandas in this case.
Okay. Okay, then maybe you can go ahead and write the logic. Ashish, let's do one thing. We'll join on the other meeting. Okay. The time is about to end. Hello. Can you hear me?
Yeah, I can.
We'll join the other
Yes,
meeting.
yes, yes.
Yeah. Okay.
Okay.
Can continue now.
Sorry.
You can share your screen and get started. Like you can finish the code which you have started, right?
Yes.
Yeah. Yeah, I can see your screen.
Now I'm doing that question, right?
Mm-hmm. Okay. See, just look at a way how you can like see a way how you can get these things readily. Okay. Pandas has got a lot of ready-made inbuilt functions to get date, hour, and everything. Just think on those lines, how you could do that.
Extract for extracting user like term, but for instance, right? So for here, what we can use? I don't remember actually. Hello.
Yes. Sorry, I can't hear you. Ashish, you there?
Yeah, actually in pandas, yeah, in pandas we can't we use what in that in SQL we use extract function, right?
Yes, yes.
Uh, the same things we can't able to use in pandas. So I am thinking like what are the functions I little bit forgot.
Have you heard of this library datetime pandas pd.datetime?
Time, yeah, I heard.
Yeah, now think on those lines. Datetime, like you can get R in that, seconds, minutes, everything is there. So
Okay.
maybe
So
try to think on those. There's a ready-made
okay.
library that
So first we need to like convert those strings into date format, right?
okay.
So
Yes,
we
very
use
good.
two, yeah. So we use two date in here. So
Excellent.
what happened? Yeah. So in that case, we use two date to reading those files. Like if you use like what are the my previous data frame file. So date is my list. So date inside the yep. So date is
See, I'll tell you. First, convert the everything into date time, and then try to think how can you get date out of it, minutes out of it, day of the week out of it. Look for a way to standardize the data first. How you can
so
make the data standard, yes.
yeah, so from here we can convert this date to the date format, and then from here we can if we extract the year,
Okay.
we can't extract date from this date. If we want to extract the
Sorry.
date, like if we store this in the but what we can use like df.date. Something like that we can
Okay. Okay. We can do one thing. Like we are on the last minute call. So maybe you can just look at a way. Maybe you can Google things like there's a library called as pd.toDateTime. Okay. So library is supported by pandas and pyspark. Okay. So in that, like whatever the line you have written from line number 22 until 32, right? 10 lines. That is not required. And one more thing I would like you to think is, see, the problem statement I've given is a very ideal one. Like you will never see a proper only single column. Okay. There'll be multiple columns, sometimes 10, 20, 30, 40, n number of columns would be there. So when you use a for loop, there itself you are dropping your performance. Okay. The code will take a lot of time because it has, since you're using pandas, moreover, pandas is a single thread. So it would go line by line, one by one, one by one. So it would take a lot of time for your code to get executed. Okay. Even here, like when you can see, like this is a feedback which I'm trying to give it to you. Okay. So whenever you work on a datetime column, right, like this is a very tricky part. Always try to make them into a standard format. Okay. It could be anything, like you want 𝗖𝗿𝗲𝗃𝗵 or 𝗖𝗿𝗵𝗃𝗵𝗃 or whatever format you want, you make them standard. Once you have the data in the standard format, then it becomes easy for you to think like, how can I extract times? Because there are a lot of libraries available. Like simply what you have done, what you could have done is first converted the event timestamp into a standard datetime format. And then once you have that, maybe you could use dt.r. That would extract the R out of it because the data is in timestamp. Pandas node, this is timestamp column. It supports a .r function, which helps you to bring the R out of it. Similarly for the date, similarly for the week. Okay. So there are a lot of things which could be done. And this would help you to improve the performance as well as you could write your code in a much more faster way. Okay. I'll be sharing that a sample code with you, like the same thing which I gave it to you. Maybe you could think and see whether what could have been done here. So I have pasted in the chat. Maybe you could like you can go through it after the call. But yeah, so overall, Ashish, maybe you can stop sharing and we can discuss any questions you have, or I can discuss on the feedback. Hello? Ashish, you there? Hello?
Yeah.
Yeah.
Due to that network connection, I think.
Yeah, like I'll take two things here. Okay,
Yeah.
here. First, I would like to give a feedback to you. Okay. And then maybe you can ask questions if you have any. Okay. So regarding your feedback, right? So you started with your project. Okay. Which is a good thing. You walked me down through your projects. Okay. But I would like you to go more inside, more deep into your projects and tell me the nits and pics of what you have done. Okay. Not what the project is all about. What you have contributed in the project, I would, as an interviewer, I would also like to know. Okay. That would be your first feedback. And second, be little bit patient to hear the complete question. Okay. Yes, there are a few instances where you know the answer, maybe by the keyword you have picked up. So let the interviewer finish the question and then maybe you can answer. You have answered the questions to the point, which is really good. I appreciate that. All the things were good, but you need bit more confidence on the way you're answering and the way you understand the question and repeat. Okay. So be a bit more confident on that. So these were the only two things which I noticed. Rest all this, you are good on the concepts, but yeah, like you need to learn more about the concept because you're a 3 years experience, right? Now when you move to another company, they would be experiencing in knowing that like you know a little bit more than what a 1 year or 2 year knows, because you might be falling into the senior data engineering role or something like that. Okay. So you need to go more into technical depth of the concepts and try to explain it in a better fashion and with more confidence. So these were the feedbacks which I would like to give. And whenever you come with a problem, a coding problem, right? Like just try to, instead of directly jumping into the solution, just try to see how can it be done. Okay. Think out loud. Like if you're thinking anything, just talk with the interviewer. He's there for helping you. Like if you could have told like, I'll convert this into this into that, maybe I could have stopped you. Don't do this, don't do that, or maybe do this way, do that way. So whatever you're thinking, it's not an exam, right? Like if you copy, there won't be any marks. Just think out loud, talk to the interviewer. Okay. Don't take the stress of the interview that anything will happen. Just talk to the interviewer that, okay, can I do this? Can I do that? Maybe he can guide you and maybe you can come up with a solution within 5 minutes. So just thinking out loud. Okay. So this will really help you in the upcoming interviews. So yeah, these were the some feedback I would like to give to. Any questions you have for me?
No, no. Like what happened now, whenever I receive some problem statement, so
Yes.
in my mind, like there are 2-3 approaches we can do in SQL, we can do in Pandas, we can do
Yes.
in PySpark. So I am a little bit confused. So
Yeah, this
what
is a
happened, like
typical problem. This is a typical problem which anyone, even
So-
when I go for interview, I would be having, because I come with a 6 years, 7 years experience. Even I know there are multiple ways to do that. But when I talk to the interviewer, right, he will tell me, if you're going with the pandas, go this direction. You have datetime format. If you're going with the PySpark, go this way. If you're going with the SQL, you have, as you have said, like you can use the extract functions and all those things. So this will help you, and also the interviewer will come to know that, okay, this guy knows about the concept. It's only about the hands-on. Okay. And for the hands-on, you have got ChatGPT and everything. Anyone can write the code, but how to write a code is what the company wants. Hello?
Yeah.
You're there?
Yeah.
Yeah. Any further questions?
Yes, sir.
Any further questions for me?
So like no, means or what should I need to like improve myself, like in that extra.
Yeah, see, in any interview, right, like they won't ask you very difficult questions. Okay. They will look at how you're answering, and then they will decide on the complexity of it. Okay. Whether to go with easy, medium, hard. Nobody would come directly with the hard questions. So when you answer the questions, try to be as crisp and simple as you could be. Don't try to complicate things. Don't try to overthink. If a question is asked, do you know skewness? Yes, I know this is the concept, but I have not implemented. So I don't know the implementation part, but I know the concept. The interview will come to know, okay, he knows some little knowledge. If given a problem statement, he would try to solve. So this way, you are setting the expectations. I am not coming with an exemption that Ashish should be knowing everything. Okay. So you are setting expectations for yourself. So whenever you answer, try to be small, simple, and crisp, to the point. Don't overthink. In the coding round, just talk to the interviewer. Sir, can I do this? Sahil, can I do that? What is this approach? What would be the best next approach? So all these things, this will help the interviewer know that, okay, Ashish knows something. It's only that he's getting confused. And I know it's an interview pressure which everyone goes through. So it's totally understandable. Just you're good right now. Maybe a little bit efforts and you will be really good to nail your next interview. Okay. Yeah.
Thank you.
Yeah. Okay. Then sure, Ashish, if you have any questions, just reach out to me. But yeah, thanks, man. All the best, and have a great day. Bye-bye.